Okay, you may not realize, but Unreal Engine actually has two rendering engines built into it. One is the deferred rendering engine, and this is on by default, and the other is called forward. Um, Now, the reason that they have two is because certain circumstances call for the use of one over the other, where one might be faster, but the other might be like more pleasing to the eyes. So, as I said, deferred rendering is typically on by default, and it's called deferred because what it does is it takes all the meshes that you see in your scene and gives them to the GPU, and it doesn't render them to the screen automatically. What it does is it pits them into layers um, like a depth layer, a color layer, an emissive layer, and it renders out all of these layers first and then composites them together, and then it does the lighting on top of that. And that's why they call it a deferred renderer, because it defers the rendering. Why it kind of does this um, composition type thing. And it's great because it's got all these different features like screen space, reflections, and it's really high end. And it's typically, if you've seen like a really good looking game in Unreal 4, it it's probably using the deferred renderer. Now, the problem arises when you're doing something in like VR where you have to render the scene effectively twice. The deferred render can be pretty slow with that because not only does it have to render out something like at a really high resolution multiple times in all these buffers or images, it has to do that twice, and it puts a strain on the GPU because you're moving so much information across, especially if you're doing it twice. And this where a forward rendering comes in. So forward rendering doesn't do all of that compilation. It doesn't compose an image based off several other ones. It just renders straight to the GPU. So it takes every mesh that you see and it renders one at a time to your GPU with the lighting as well. It can be pretty intense, but compared to deferred, it's definitely a bit more streamlined. Another thing is the way that we use anti-aliasing works different on both. So I believe deferred uses temporal anti-aliasing, which is meant to be really good for like organic shapes, like if you're doing like leafy objects, trees, something like that there. It kind of smooths them off and it's really nice. Where forward rendering uses MSA, so it's multi-sampling anti-aliasing, and this can actually look better in certain circumstances, especially if you're doing like more architecture-based stuff, like say this city where it's got like very straight lines, it's very rigid. MSA does a really good job of smoothing out those types of lines and making it crisper. So in certain circumstances, you can actually find like a forward render gives you like a better result in those terms. There's some things that you do lose though, like screen space reflections is one of them. So we kind of have to use more pre-computed ones, which is fine, like for mobile and VR, that's what we should be typically using anyways. And I'll make a video on that there. But to set up your forward render, it's really, really simple. I've already done this project, so that's why we're getting all these compiling shaders because it has to recompile all the shaders because we're doing a forward renderer now. If you just go into your project settings and search for like forward rendering, it'll be just called like forward renderer or forward shading, and you just click that box. It'll ask you to restart, and once you do, it will take a long time to compile these shaders, I know, but it's going to be worth it, all right? And it's definitely something that you should be doing, especially for VR. Mobile, you could probably get away with using the deferred render because it's not having to render the scene twice. But for, definitely like VR, I would say go for the forward render.